Hurricane Ian brought a tremendous amount of rainfall to the Central Florida region. While the hurricane's most destructive forces hit southwest Florida, the Central Florida region within our district suffered historic rainfall and flooding as the storm moved across the state. As part of our flood protection mission, the district employs both structural and non-structural strategies. Our only active structural flood protection is in the Upper Ocklawaha River Basin, shown here, and the Upper St. Johns River Basin, shown here. Note that both of these rivers flow from south to north. All of the district's water control structures performed well and as designed during this storm. But Hurricane Ian crossed the St. Johns River Basin at a point downstream of the water control structures, in an area where many tributaries flow into the main stem of the St. Johns River. This leads to my special hydrologic conditions report, in which I will report on the flooding and record high water levels caused by Hurricane Ian's transit over the district. To give some perspective on the amount of rain and flooding in Central Florida, I captured color infrared satellite imagery of part of the Middle St. Johns River Basin in Central Florida. Color infrared imagery makes water more distinguishable in the landscape. This particular image was taken prior to Hurricane Ian. You can see a well-defined river channel between Lakes Harney and Lake Monroe from here to here, and you can also see inundation along the floodplain and wetlands south of Lake Harney. This image from September 30th shows water levels after Ian. The floodplain is inundated south of Lake Harney, with flooding stretching towards Titusville and Mims area. There's also significant flooding around the river's main channel between Harney and Monroe and around the lakes themselves. These maps depict the rainfall accumulation from the start to the end of the storm. On the left map, on September 26th and 27th, our region received some rainfall from outer bands of the storm. The middle map adds in the rainfall from September 28th. We're beginning to see greater rainfall accumulation in the Orlando area and in Volusia and North Brevard counties. However, the bulk of the rainfall came in the final day of the storm, Thursday the 29th. This area saw large and rapid accumulations totaling 15 to 20 inches and even more in some areas. During events like the hurricane, the district relies on web tools maintained by the National Weather Service to monitor current flood status as well as forecasted flood status. These tools utilize monitoring data collected by the U.S. Geological Survey, which the district co-funds. Using information derived from these tools, we can illustrate the impact of Ian's rainfall on the St. Johns River overall, looking at 12 days of flood status for 6 stations along the St. Johns. The river stations in the chart correspond to the red stars on the map. We see Jacksonville, Buffalo Bluff, Astor, DeLand, Harney, and Cocoa. The colors in the chart correspond to the degree of flooding at each station on each day. You can see that the entire length of the river was impacted by flooding to some degree, but the Middle St. Johns River Basin, as represented here by Astor, DeLand, and Harney, experienced persistent major flooding and record water levels. The flooding persisted long after the storm and its associated rainfall had moved through the area. Another way of summarizing the record water levels caused by the hurricane is this preliminary map depicting the locations of USGS stations where records were broken. It includes not only main stem St. Johns River stations, but also many tributaries. We also saw record high water levels at numerous district monitoring stations for surface water and surficial wells. The greatest density of these, is not surprisingly, corresponds with the areas that had the most rainfall. And this leads me to a more focused examination of the Middle Basin flooding. The white boundaries on this map are the drainage basins that contribute to the Orlando area lakes. These basins received some of the highest rainfall totals experienced in the storm, especially the Lake Harney and Jessup basins, which are here and here, each of which received 15 to 20 inches of rainfall over most of their area. The Middle Basin also experienced extreme flooding because of its position in the landscape and its susceptibility to the strong and persistent northeast winds that we experienced during Ian. The nor'easter-like conditions drove winds from the mouth of the river southward along much of its length. As a result, there was significant reverse flow at Buffalo Bluff. The flow at Astor was also reversed for a couple of days. These reverse flows caused by the wind downstream of the Middle Basin exacerbated the flooding from the enormous amount of rainfall that the Middle Basin had to absorb. This slide highlights what was happening in some of the tributaries in the Middle Basin. And let me point them out. This star is the Econ River Station, this is Howell Creek, and this star here is the Wekiva River Station. Immediately after the storm, the USGS took measurements in the field, recording some astounding readings. Flow dwarfed the normal flow for this time of year. For example, the flow in the Econ River was 15,000 cubic feet per second, which was 42 times greater than the norm for this time of year, which was 350 CFS. In contrast, the input from the Upper Basin Station was around 2,500 cubic feet per second, which was only about 1.5 times greater than normal. The Upper Basin did receive less rainfall than the Middle Basin, but that's only part of the story. The difference in the magnitude of flooding illustrates the value of undeveloped floodplain in the Upper Basin for absorbing and storing rainfall from such large events. And as an example of that, this aerial photograph taken on October 6th is the district's River Lakes Conservation Area. This is an example of undeveloped floodplain. The district's land acquisition program prioritizes the acquisition of floodplain like this as part of its flood protection and natural systems core missions to preserve these natural areas that store floodwaters during large events. In total, the district owns more than 300,000 acres of land that FEMA considers to be within the 100-year floodplain.